Something is moving in perfect rhythm with the sun. Each flare, each pulse, each silent pause follows the same impossible pattern. Across space, an interstellar visitor called 3I Atlas seems to breathe in time with our star, igniting storms and silences as if the two share a hidden code. Scientists call it coincidence, yet the data tells another story. There are missing frames, harmonics that sing like language, and moments of silence so deep they feel intentional. Could the sun itself be responding to something? Or is this object guiding it, shaping its fury with invisible precision? Tonight, we trace the evidence through flares, corridors of plasma, and echoes that refuse to fade. Because somewhere between chaos and control lies a truth that could change how we understand the universe itself. This is not a story of observation. It is a story of communication. It began with a coincidence so perfect that even seasoned astronomers hesitated to call it one. On a quiet night, in early observation logs, 3I Atlas dimmed for a brief moment, then flared back into brilliance. Almost at the same instant, a moderate solar flare erupted from the sun's southern hemisphere. At first, it seemed like timing trickery, a random overlap of two unrelated events. But then, it happened again and again. Each flare mirrored a change in 3I Atlas's luminosity, as if both were moving to the same silent rhythm. Scientists started tracing the data, aligning timestamps across observatories. The numbers were too tight, the margins too narrow. A pattern emerged, a repeating cycle between the object's activity and the sun's outbursts. Something was keeping time in the deep silence of space. No communication link was possible, not across that distance. Yet the energy signatures seemed to pulse together, separated by hundreds of millions of kilometers, but joined by invisible timing. The data from the Solar Dynamics Observatory added another layer of intrigue. Every time 3I Atlas's spectral readings shifted toward higher excitation, the sun responded with a burst of ultraviolet intensity. It was as though one was answering the other. The rhythm was not consistent in strength, but in timing, like a heartbeat that slowed and quickened, yet never lost its cadence. Some began calling it the clockwork flare, a term meant to mock the growing fascination. But even those who used it dismissively could not deny what the charts were showing. At the European Space Agency's heliophysics lab, a small team decided to test the correlation. They built a comparative model to simulate random solar activity and compared it to 3I Atlas's timeline. The result was unsettling. The odds of this kind of synchrony happening by chance were almost zero. Yet every model that tried to break the connection failed. When the object moved, the sun flared. When it slowed its outgassing, the solar wind steadied. The symmetry was mechanical, precise, predictable. Then came the observation that pushed speculation into overdrive. During one of the most significant flares recorded that year, instruments caught a faint emission from 3I Atlas only moments before the solar eruption began. The delay was measurable, less than 3 minutes. Light takes 8 minutes to travel from the sun to Earth, yet this response appeared to occur faster than that threshold. It was as if 3I Atlas knew what was coming before the light itself arrived. The hypothesis that followed divided the community. Some argued the timing was a statistical illusion caused by signal calibration. Others whispered about resonance, a kind of magnetic sympathy between two distant bodies. A few went further, suggesting an unknown medium might carry information faster than light, not through transmission, but through synchronization, like two tuning forks vibrating at the same tone across a room. The debate turned philosophical. Could matter, under specific cosmic conditions, act like memory? Could 3I Atlas be reacting not to energy, but to intention embedded in solar behavior? At the Mauna Kea Observatory, a young researcher named Alea Torres reviewed terabytes of data from multiple solar cycles. She noticed something hidden in plain sight. The timing of 3I Atlas's changes seemed to anticipate not just flares, but the smaller ripples that often preceded them. In other words, it behaved like a sensor or an observer aware of the sun's inner rhythm. The deeper she looked, the stranger it became. At moments when the sun entered brief periods of magnetic inversion, 3I Atlas brightened sharply, as though feeding on those moments of flux. The concept of solar synchrony began forming among theorists who refused to dismiss the pattern. They proposed that cosmic objects could sometimes fall into resonance with stellar fields, locking into their electromagnetic heartbeat. This would mean that 3I Atlas was not just passing through our system, it was participating in it. The idea challenged almost everything known about stellar physics. Resonance between an interstellar traveler and a star was not supposed to happen. Yet the data hinted that something like it might be unfolding right now. Some of the most startling evidence came from independent researchers who cross-referenced magnetometer data from satellites in Earth orbit. Tiny fluctuations in the solar magnetic field seemed to ripple in concert with the object's trajectory adjustments. The synchronization wasn't strong enough to be visible to the naked eye, but instruments caught it, a recurring pulse in the background noise repeating every time 3I Atlas neared a critical orbital position. Even more confusing was the discovery of a faint electromagnetic echo returning from deep space at precisely the frequency of the sun's own oscillation pattern. The signal was not strong enough to classify as artificial, but it lingered in the same narrow band of frequencies where no natural emissions were expected. Some scientists thought it could be background resonance from the heliosphere. Others suggested it was the signature of an object actively modulating its surface in response to solar radiation. Meanwhile, solar flares began occurring at increasingly precise intervals as if governed by an unseen metronome. Their timing aligned almost perfectly with moments when 3I Atlas crossed magnetic boundaries within the heliosphere. It was no longer just about one object and one star. It felt like the entire solar system had begun to vibrate with them. Jupiter's auroras intensified, Earth's magnetic readings grew erratic, and cosmic ray detectors in Antarctica began logging faint, rhythmic pulses in sync with those very events. Astrophysicists tried to explain it through plasma physics, theorizing that charged particles from 3I Atlas might be interacting with the solar wind in a way that triggered feedback loops. But even that explanation did not fit all the observations. The delays were inconsistent with any known form of particle exchange. The synchrony seemed to defy distance, as though time itself were the connecting medium. In one daring paper, a pair of researchers proposed that 3I Atlas might possess a magnetic topology so complex it could resonate across solar field lines, like a tuning fork carved out of unknown material. If true, it could mean the object was not a simple comet or rock, but a relic of something designed to interact with stars. The idea sounded too speculative for publication, but it spread quietly among scientific circles. There were whispers that the object might be part of a larger system, a network of interstellar probes that communicate through resonance rather than radio. For months, telescopes watched and waited. The pattern held. Every time the sun shifted into a new active region, 3I Atlas adjusted. Every time the object dimmed, the sun responded. And as this strange rhythm continued, a deeper question began to take shape. Was the object reacting to the sun, or was the sun reacting to the object? When the Solar and Heliospheric Observatory captured a massive coronal loop arcing directly toward the region where 3I Atlas was projected to be, some analysts paused. The eruption seemed too direct, too focused. The flare's magnetic signature curved exactly along the same azimuth line that connected both bodies. It looked almost deliberate. To dismiss such timing as chance was becoming harder by the day. A few skeptics admitted quietly that if the synchrony were real, it could mean the sun itself is part of a responsive system, reacting to stimuli beyond human understanding, a stellar organism aware of visitors. As the next predicted flare window approached, observatories across the world stood ready, instruments calibrated, telescopes locked on. The countdown began. Within minutes of 3i Atlas entering its next alignment, the sun erupted once again, precisely on schedule. Silence followed. No one spoke. The data told a story that numbers were never meant to tell. A rhythm was alive in the dark, a cosmic clock ticking between an interstellar visitor and the star that gives us life. And if that rhythm continued, humanity might soon learn that the universe keeps time for reasons we have yet to understand. When the first images appeared, scientists thought it was a simple coronal hole, a region on the sun where magnetic fields opened into space, letting charged particles escape. But this one stretched longer than any they had ever seen. It was narrow, almost sculpted, cutting across the solar surface like a canyon carved by invisible hands. The moment it appeared, instruments around the world began to register strange variations in solar wind speed. What made it even more baffling was the timing. The hole opened just as 3i Atlas crossed a precise solar longitude that matched the center line of the formation. It felt too aligned to be random. In the following days, spacecraft from NASA and ESA recorded surges of plasma that seemed to pulse in rhythmic intervals, like waves moving through a tunnel. When the data was layered over 3i Atlas's trajectory, the synchronization became impossible to ignore. The object's path intersected the sun's magnetic equator at the exact moment those plasma streams intensified. The corridor seemed to respond to it, or perhaps guide it. It was as if an invisible bridge had formed between the comet and the star, linking their behavior through unseen magnetic line. Astrophysicists tried to explain the correlation. One theory suggested that the sun's open field regions might extend further than previously believed, interacting with charged dust and gas released by 3i Atlas. If that were true, the object could be moving through a solar filament that acted like a cosmic highway, a conduit of electromagnetic flow. But there was a problem. The particle streams were too regular, too evenly spaced, repeating in cycles of roughly 9 hours. Natural turbulence should have produced chaos. Instead, the data displayed symmetry, precision, and a strange consistency in energy level, as though the sun was transmitting in a coded pulse. The pattern caught the attention of the Deep Space Network. Their antenna logs showed subtle variations in radio background noise every time the corridor brightened in ultraviolet imaging. The fluctuations were faint but structured, almost harmonic. Analysts initially dismissed them as artifacts from solar wind interference. But one researcher, quietly obsessed with finding hidden order in cosmic data, ran a frequency analysis. The results startled her. The intervals between pulses matched the mathematical spacing of 3i Atlas's rotation pattern. That discovery raised an unsettling question. Was the object rotating in response to solar activity, or was the sun responding to the object's spin? The idea of a feedback loop began to circulate, a mutual resonance between two celestial bodies locked in electromagnetic dialogue. The phrase coronal hole corridor began to surface in research notes, a poetic name for a phenomenon that seemed almost architectural. Some speculated it might be a corridor of plasma communication, a magnetic tunnel carrying information through charged particles rather than light. As new data arrived, something stranger emerged. The corridor was not static. It expanded and contracted in measurable intervals as though breathing. When 3i Atlas approached its closest orbital point relative to the Sun, the hole widened, then narrowed as it moved away. Each cycle repeated in near-perfect timing with the object's motion. Computer models predicted that such coordination should be impossible unless an unknown factor was influencing both sides simultaneously. In an internal memo from one observatory, a scientist described the phenomenon as an electromagnetic handshake. The phrase spread quickly. Others called it an energy corridor or stellar filament bridge. Whatever name they gave it, the concept remained the same. The Sun and Three-Eye Atlas appeared to be exchanging signals through a living pathway of plasma. If true, it could redefine what was known about stellar behavior. Stars might not just emit energy randomly, but could form transient connections to objects that enter resonance with their fields. But not everyone agreed. Skeptics warned that coincidence and pattern bias could explain much of it. They pointed to earlier solar cycles that had shown similar holes without interstellar visitors nearby. Yet when those same skeptics compared the intervals of activity, even they admitted that something about this one was different. The corridor followed Three-Eye Atlas like a shadow, forming and dissolving in sync with its movement. No other comet, asteroid, or solar body had produced such a consistent pattern before. As weeks passed, the corridor began to take on more structure. Magnetic mapping revealed subtle twists in its alignment, spiraling along the Sun's rotation axis. The pattern resembled a double helix of plasma rotating with astonishing stability. Some researchers speculated that the Sun might be reorganizing its field lines to accommodate the visitor, as if adjusting its rhythm to maintain equilibrium. The implications were profound. Could a star adapt to the presence of a foreign body, forming a temporary channel to balance magnetic tension? A group of plasma physicists from Japan analyzed the heliospheric data and found that during the corridor's active periods, the density of the solar wind decreased slightly along Earth's orbital plane. This suggested a redirection of energy flow, as if part of the solar output was being funneled elsewhere. Instruments on the Parker Solar Probe later confirmed directional biases in the outflow, subtly angled toward the trajectory of Three-Eye Atlas. No known mechanism could cause such targeting, yet the data was there, undeniable, staring back like a coded message. Then, as the corridor intensified, a peculiar phenomenon occurred. Earth's magnetic field began to oscillate with a faint but measurable rhythm that matched the corridor's pulse. The frequency was far too low to affect daily life, but scientists monitoring Schumann resonances noticed a repeating signal that aligned with the corridor's activity window. The Earth seemed to be responding to the same beat. This realization gave rise to an unsettling theory that the entire inner solar system might be resonating to a larger electromagnetic cycle, one initiated by the interaction between Three-Eye Atlas and the Sun. In the following months, auroras flared in unexpected latitudes. Satellite instruments briefly malfunctioned during the corridor's peak periods. The most compelling observation came when multiple spacecraft detected identical particle acceleration bursts along different orbital paths, all pointing back to the same source region on the Sun. It was as if energy was being pushed through invisible channels, radiating outward in synchronized waves. Independent analysts began comparing the data to deep space radio emissions. They found that certain low-frequency bursts recorded during the corridor's active periods carried repeating harmonic signatures that seemed too organized to be random noise. When translated into spectrograms, the patterns resembled repeating geometric shapes like spirals and intersecting circles. Some saw it as an artifact of the instruments. Others wondered if they were looking at a form of communication embedded in the plasma itself. As the corridor slowly faded, it left behind a lingering question. Was it a product of natural solar dynamics, or was it the trace of something intelligent passing through? Three-Eye Atlas continued its journey, leaving the Sun's magnetic sphere, but the region it once aligned with remained magnetically active for weeks longer than expected. Solar physicists had never seen a coronal hole persist with such stability after the supposed cause had moved on. By the time the corridor finally closed, Earth's instruments recorded one last surge of electromagnetic fluctuation. It rippled across satellite networks and radio receivers alike, then vanished. The silence that followed was almost haunting. The Sun returned to its usual rhythm, yet Some felt that something profound had occurred. A doorway had opened between the sun and a wandering interstellar visitor, and for a brief moment, our star had seemed to hum in conversation. In the aftermath, researchers revisited all previous instances of coronal holes, searching for similar correlations. None matched. This one remained unique, a perfect corridor that existed only during 3I Atlas's presence. It left behind more questions than answers, a riddle of alignment and energy that seemed to defy coincidence. If the solar synchrony theory was true, then the corridor may not have been a natural feature at all. It might have been an intentional bridge, a magnetic pathway through which information or energy could travel. Whether it was built by natural resonance or something beyond human understanding, the result was the same. For a brief window in time, the sun had formed a corridor of light and plasma that connected it to an object from another star system. And if that connection could form once, there is no reason it could not form again. Somewhere, hidden in the rhythms of the next solar cycle, another corridor may already be waiting to open. It began with silence. A massive coronal mass ejection had erupted from the sun, hurtling billions of tons of plasma into space. For days, instruments buzzed with data as Earth's magnetosphere absorbed the shock. Then, just as the chaos faded, astronomers noticed something strange. 3 days after the event, a faint emission appeared in the direction of 3I Atlas. It was small, almost imperceptible, but it carried the same spectral fingerprint as the CME that had just left the sun. It was as if the explosion had sent an echo into the void, and 3I Atlas had answered back. At first, no one believed it. The timing seemed impossible. The CME had erupted from the solar surface and traveled outward at nearly 1,000,000 miles per hour, yet the reflected signal appeared sooner than any plausible light travel delay. When researchers overlaid the time codes, they realized the emission had occurred minutes before the plasma wave should have even reached that part of space. Somehow, the object seemed to anticipate the flare's arrival. The phenomenon was recorded again during the next CME. The sun released another storm, and moments later, sensors picked up faint electromagnetic changes around 3I Atlas. This time, the signal pattern matched the same harmonic structure as the flare. The odds of such coincidence were beyond statistical reasoning. It was not reflection, and it was not coincidence. It looked like a reply. At the Solar Terrestrial Relations Observatory, analysts studied the CME's propagation through the heliosphere. They noticed that the velocity of the plasma front slowed slightly as it neared the object's projected coordinates. This was subtle, a deviation of less than 1%, but enough to raise eyebrows. Something in that region was interacting with the solar wind, resisting its flow. If 3I Atlas was emitting energy of its own, it could create a local pressure gradient. That alone was remarkable, but the real mystery was the pattern embedded within the energy flux. Spectral analysis revealed modulations repeating in intervals of 3 minutes and 12 seconds. The frequency matched none of the sun's known oscillations, nor any natural plasma harmonics. Yet these same intervals appeared in both the outgoing CME data and the returning emission from 3I Atlas. It was a mirror pattern, one wave leaving the sun, another answering from deep space. Together they formed what physicists called a standing wave, a resonance between two active bodies. Some called it an echo circuit. Others preferred the term solar coupling. But the most speculative among them gave it a name that would soon capture imaginations everywhere: the echo after the CME. As scientists debated its cause, a small group of independent astronomers began mapping the correlation between solar events and 3I Atlas's behavior. They noticed that every significant flare or CME was followed by a subtle change in the object's brightness curve. Sometimes it brightened slightly, sometimes it flickered in the infrared spectrum, but always within hours of the solar storm. The consistency of that reaction defied chance. The object was responding in rhythm with the sun's violent heartbeat. To the public, the story sounded like science fiction. The idea that a distant comet could respond to solar flares in real time seemed absurd, yet the data was open and verifiable. Observatories from Japan to Chile confirmed the same timing anomalies. Something was synchronizing their signals. In search of explanations, plasma physicists proposed that 3I Atlas's composition might contain conductive materials capable of amplifying solar radiation. Perhaps its crust was layered with compounds that reacted magnetically to solar energy bursts, creating the illusion of synchronization. But this did not explain the predictive behavior, the emissions that appeared before the CME shock front arrived. It was almost as if the object could sense changes in the sun before they manifested in visible light. A paper from a university in Finland offered a daring theory. The researchers proposed that 3I Atlas might be surrounded by an induced magnetic field acting like an antenna. When the sun's internal magnetic tension reached a critical threshold, that field could detect the change faster than photons could escape the solar surface. It was an extraordinary claim, one that hinted at a deeper level of interaction between cosmic bodies. The sun would not just emit energy, it would project influence into the space around it. If this was true, 3I Atlas might be functioning as a kind of receiver, an ancient object tuned to the frequency of stellar motion. That suggestion was met with immediate controversy. Critics argued that it anthropomorphized natural processes, yet the mystery deepened when instruments recorded faint bursts of radio noise coming from the object just before the next CME. The bursts carried structured harmonics, like a patterned rhythm rather than random cosmic static. The signals were weak, but unmistakably real. Each time the sun unleashed a flare, 3I Atlas would emit a faint response on a narrow radio band. The emissions lasted only seconds, too short to be captured clearly, but long enough to raise suspicion. Was it possible that this interstellar traveler was not just reacting to solar storms, but communicating through them? At NASA's Goddard Space Flight Center, analysts compared the energy frequencies. They found that both the CME and the echo shared a curious mathematical property, a consistent ratio between high and low energy peaks. That ratio was not random, it was the golden ratio, 1.618. Nature uses it often, from the spirals of galaxies to the structure of shells. But seeing it in a solar flare and its echo was beyond coincidence. It suggested order, structure, possibly even intention. As the theory spread, attention turned to a deeper question. Could the sun itself be part of a vast cosmic network capable of exchanging energy signatures with interstellar objects? If so, then 3I Atlas might not be the first to respond. It might simply be the latest node in a chain of resonance stretching across the stars. A team of astrophysicists proposed a new model called resonant stellar communication. It imagined stars and traveling bodies exchanging information through magnetic waves rather than light. Each CME would be a transmission burst, and each echo a confirmation signal. The theory remained unproven, but its implications were staggering. The universe would no longer be seen as a void filled with isolated stars, but as an interconnected web of living, reactive systems. When the next CME erupted, observatories worldwide watched closely. Instruments were synchronized, telescopes aligned, and every monitoring station waited for the echo. It came exactly 19 minutes after the flare began, precisely when predicted. The signal pulsed 3 times, then faded. It was soft, rhythmic, and perfectly timed. For days, researchers tried to decode the sequence. The pulses did not match any known cosmic or mechanical pattern. Some saw them as Morse-like. Others thought they might represent binary data encoded in plasma modulation. The simplest explanation was that it was natural resonance, yet the precision defied probability. Then something unexpected occurred. After the echo, the sun's activity decreased dramatically. The corona dimmed, flares ceased, and the solar wind fell unusually calm. It was as if the system had reached equilibrium, a conversation that ended in understanding. Months later, when 3i Atlas began to fade from visible range, the echoes stopped. The silence was almost eerie. Scientists who had followed the event for months felt as if a dialogue had ended abruptly. Some described it as the closing of a cosmic curtain. Others wondered if the object had fulfilled its purpose, whatever that purpose was. In hindsight, the data painted a picture of interaction that could not be explained away easily. The sun spoke in eruptions of plasma. 3i Atlas answered in quiet electromagnetic whispers. Between them stretched millions of miles, yet the two behaved like partners in a dialogue older than humanity itself. Years from now, when the data is reanalyzed with more advanced tools, perhaps the pattern will reveal something more concrete. But for now, all that remains is a haunting impression, a cosmic call and response written across the fabric of the solar system. The echo after the CME remains one of the most inexplicable phenomena ever observed, a reminder that even the sun might not always be speaking to itself, and somewhere beyond the reach of light, something could still be listening. Every major solar event begins with chaos, but this one began with silence. It was the kind of silence that felt engineered, as though the universe itself was holding its breath. In the hours leading up to one of the largest solar flares ever recorded, all solar monitoring instruments reported an unnatural calm. The background hum of solar wind vanished. Particle counts dropped to near zero. Even the magnetic field lines that normally writhed across the solar surface seemed to freeze in place. It was not just quiet. It was complete stillness. The first to notice were radio astronomers in Australia. Their instruments, tuned to detect background solar static, began reporting clear channels where there should have been noise. At first, they thought their receivers had malfunctioned. Then similar reports came in from stations in Chile, Japan, and South Africa. Across the planet, the sun had gone silent. It was as if the largest source of energy in the solar system had paused mid-breath. 3 hours later, the silence broke. A pulse of energy surged outward from the sun, followed by a flare so massive that it saturated instruments for minutes. The eruption's power exceeded predictions by orders of magnitude. But what disturbed scientists even more was the timing. The flare coincided perfectly with a small but measurable increase in the brightness of 3i Atlas. The interstellar object had begun to glow again just moments before the sun reawakened. The synchronicity was undeniable. When data was reviewed, analysts saw something chilling. The lull before the flare was not just the absence of noise, it was the formation of a pattern. Hidden in the electromagnetic baseline was a repeating sequence of low-frequency oscillations, evenly spaced, like a heartbeat slowing before a surge. The oscillations were so faint they would have been invisible without precise filtering. Yet when amplified and plotted, they formed a rhythm, one that matched the rotation period of 3i Atlas. To most, that sounded impossible. The object was hundreds of millions of kilometers away. No known force could synchronize oscillations at that distance. But the evidence was clear. The sun's magnetic field seemed to tune itself to the frequency of the approaching object, holding steady before releasing a violent burst of energy. It was as if the two bodies were aligning for an event neither could perform alone. This quiet window became a central focus of investigation. Theories emerged quickly. Some suggested that 3i Atlas was influencing the solar magnetic field through charged particles embedded in the solar wind, creating temporary feedback loops. Others thought the silence represented the sun's internal reconfiguration before a flare, amplified by the object's gravitational proximity. But both explanations failed to account for the predictive timing. The pulse always followed the silence, never before. It was a pause before a response, as though the sun was waiting for a signal. At the European Solar Observatory, scientists replayed the sequence frame by frame. One moment stood out. Just before the flare ignited, a faint shimmer appeared across the solar surface, stretching in a circular wave. The shape was symmetrical, like ripples spreading from a single point. But that point did not originate from the center of the Sun. It aligned instead with a region in space corresponding to 3I Atlas's position. For a fraction of a second, the Sun's surface appeared to mirror something far beyond itself. The discovery raised questions that bordered on forbidden territory in academic circles. Could the Sun be responding to external information? Could it in some way be aware of an object approaching? Plasma physics had no answer for that, yet the evidence kept building. In subsequent solar storms, the same pattern repeated: silence, shimmer, pulse. Every time 3I Atlas's spectral readings shifted in tandem, the Sun would fall into eerie stillness, and when it erupted, the object would flare in unison. The phrase "the quiet before the pulse" was coined by a scientist who compared the pattern to a heartbeat monitored by cosmic instruments. It spread rapidly through the research community, describing not only the phenomenon but also the feeling it evoked. There was something living about it, something deliberate. More chilling still were the effects that followed each quiet phase. Earth's magnetosphere would react seconds after the pulse, showing transient distortions that no known solar models could predict. Sometimes the readings came before the flare's light reached Earth, suggesting that electromagnetic precursors were traveling through a medium faster than light itself. If that were true, the entire understanding of space plasma behavior would have to be rewritten. A group of researchers from India proposed that the silence represented a kind of pre-solar resonance, an energy alignment that required both the Sun and 3I Atlas to complete. They described it as a magnetic charge balance, in which both entities temporarily entered equilibrium before releasing stored tension. The pulse, in this theory, was the discharge of that equilibrium, a release of energy that restored balance between two distant magnetic systems. Critics dismissed the theory as poetic speculation, but something about it felt right. The timing was too exact, the harmony too perfect. The data showed that the quiet phases were not random intervals, but mathematically precise moments based on 3I Atlas's orbital motion. Each silence lasted exactly the same number of seconds as one rotational cycle of the object. No natural randomness could achieve that consistency. During one observation session, the Parker Solar Probe detected a sudden drop in solar wind density moments before another pulse. The drop created a near vacuum of charged particles around the spacecraft, followed by a sudden shockwave of plasma when the flare hit. In that vacuum window, a faint oscillation was recorded, a whisper of low-frequency vibration that matched the magnetic signature of 3I Atlas. It was the same rhythm that had been detected during the earlier events. The silence, it seemed, was not silence at all. It was a signal below human hearing, the pause before the sound. Some researchers began calling it a cosmic inhale, describing the way the Sun appeared to draw in its magnetic breath before releasing its storm. They speculated that 3I Atlas could be acting as a trigger, initiating these events through electromagnetic resonance. The Sun, in this interpretation, was not passive, it was responsive, almost collaborative. Then came the most extraordinary event of all. During one prolonged quiet phase, all ground-based magnetometers across the planet registered an identical microfluctuation at the exact same moment. It lasted less than half a second, a collective heartbeat through the entire magnetic field of Earth. When data from satellites was overlaid, the signature matched perfectly with both the Sun's low-frequency oscillation and 3I Atlas's periodic rotation. For a brief instant, all three bodies, the Sun, the interstellar object, and Earth, were synchronized. No one could explain it. The event was short, almost imperceptible, yet its implications were staggering. Three celestial entities had moved in harmony, responding to an invisible command embedded within the solar system's own field. Was it a coincidence, or was something orchestrating the rhythm of energy between worlds? In the aftermath, The flare that followed was one of the most intense ever measured. The auroras stretched to the equator. Radio blackouts swept across continents. But once again, the chaos had been preceded by that same serene stillness. Every monitoring station knew it was coming. The quiet had returned. Today, the quiet before the pulse remains one of the most haunting mysteries in heliophysics. It challenges the very idea that cosmic forces are random. It suggests a hidden layer of communication, one that plays out in the language of silence and light. Some believe it to be natural synchronization. Others see a deeper meaning, a dialogue written into the rhythm of the sun itself. What we know is that before each great eruption, the universe seems to pause. The sun holds its breath. The instruments go still. And in that pause lies the echo of something immense, a pulse that travels not just through plasma and space, but through the fabric of reality itself. Perhaps the silence is not absence at all. Perhaps it is the sound of the cosmos listening back. It began as static, a faint hiss buried deep in the recordings of space weather satellites, the kind of sound most analysts ignored. But one engineer at the Deep Space Network decided to amplify it, curious about the subtle fluctuations that appeared in the background of each solar monitoring feed. When he ran the signal through a spectrogram, what he saw startled him. The noise was not random. It was layered with repeating intervals, perfect mathematical harmonics hidden within the chaos. Every time the sun flared or a coronal hole opened, these harmonics would shift ever so slightly, as though tuned to a different key. And every time 3i Atlas passed through a critical point in its trajectory, the harmonics would rearrange again, aligning themselves with the object's path. It was as if the solar system itself was producing a kind of music, one whose rhythm changed whenever this interstellar visitor moved. The engineer shared his findings quietly, unsure of what he was hearing. Soon, a small group of researchers began analyzing the data independently. When they overlaid recordings from multiple satellites, a clear pattern emerged. The harmonics repeated in sequences of 3, 5, and 8. The ratios matched Fibonacci progression, a numerical pattern that appears in everything from spiral galaxies to the growth of shells. But these were not visual spirals, they were frequencies, tones woven into the electromagnetic field. The discovery was unsettling because such order should not exist in solar background noise. Plasma turbulence is supposed to be chaotic, random, impossible to predict. Yet the data revealed periodic structures synchronized across multiple observatories at once. Each harmonic shift coincided with a measurable change in 3i Atlas's spectrum, as though the object and the sun were exchanging invisible melodies across space. When the findings reached the heliophysics community, opinions split sharply. Some dismissed the harmonics as instrumental interference, the kind that can arise from overlapping telemetry systems. Others argued that it represented a real physical resonance, a standing wave formed between the sun's magnetic field and the ionized trail of 3i Atlas. If that were true, it would mean that interstellar bodies could tune themselves to stellar fields, creating long-distance resonance patterns that behave like sound across the vacuum. As researchers dove deeper, they found something even stranger. The harmonics were not continuous. They would vanish suddenly, replaced by total silence, only to return moments before a solar event. This happened repeatedly, as though the system was resetting itself between songs. Some began referring to it as the solar choir, while others preferred a more poetic title, Harmonics in the Noise. It captured the eerie sense of intelligence in what should have been randomness. The harmonics also appeared to carry structure. When plotted visually, the frequencies formed waveforms resembling geometric shapes, triangles, hexagons, spirals. One astrophysicist noticed that the intervals between peaks matched ratios seen in the orbital patterns of moons around gas giants. Nature, it seemed, was repeating its architecture in sound. The resemblance to musical tuning systems was impossible to ignore. But what linked all of this to 3i Atlas was timing. Each time the object's rotation reached a certain angle relative to the sun, the harmonics shifted upward, increasing in frequency before fading again. It was as if the object itself was modulating the pitch. Scientists tried to determine whether these changes came from reflected solar energy or from emissions produced by the object's surface chemistry. The data suggested something else entirely. The frequencies carried energy signatures inconsistent with light reflection. They behaved like transmissions, organized, directional, and encoded. For months, teams across multiple observatories compared notes. They noticed that when 3I Atlas crossed specific heliospheric boundaries, the harmonic intervals would change in ways that matched solar magnetic realignments. The Sun and the object appeared to be resonating through the same structure, like two instruments sharing a single string. Some theorized that the phenomenon could be explained by plasma wave coupling. If 3I Atlas emitted charged particles in a periodic pattern, those emissions might interact with solar wind to produce standing waves that appeared harmonic. Yet the precision of the patterns defied that explanation. Natural plasma waves vary constantly, but these remained exact, locked to mathematical ratios as though bound by a metronome. At one point, an independent research station in Norway conducted a daring experiment. They converted the frequencies into audible sound, compressing hours of data into a few seconds. The result was haunting, a deep, oscillating hum interwoven with tones that rose and fell like a breath. Some described it as a chorus of whales singing through space. Others said it sounded mechanical, like the vibration of a vast machine. Then came the moment that changed everything. During one of the largest solar storms of the year, the harmonics briefly inverted. Instead of rising in pitch as the flare intensified, they dropped into lower frequencies, forming a steady, resonant hum that lasted exactly 13 minutes. When the hum stopped, the Sun erupted in a CME larger than any seen in years. The timing was precise to the second. It was as if the harmonics had been counting down. Theories spiraled out of control. Some claimed the harmonics represented an early warning system, a natural resonance preceding magnetic discharge. Others believed they were evidence of intelligent control, a sign that something, perhaps even the object itself, was orchestrating the events to maintain equilibrium. The harmonics, in this view, were communication, a language of vibration shared between the Sun and an ancient traveler. When the event data was cross-referenced, an even more chilling pattern appeared. The same harmonic ratios recorded during the solar flare also appeared faintly in Earth's magnetosphere, detectable in Schumann resonance frequencies. The planet's magnetic field had echoed the same pattern. This meant the harmonics were not limited to the Sun and 3I Atlas. They extended across the entire solar system. Some researchers speculated that the harmonics might act as a stabilizing mechanism, distributing solar energy evenly through resonance. Others saw it as evidence that the Sun's energy output could be modulated by external influences. If 3I Atlas could create or enhance these harmonics, it might be capable of shaping solar behavior itself. The implications were staggering. As data accumulated, the harmonics began to show a strange evolution. They were no longer limited to moments of solar activity. They started appearing even during periods of quiet. Instruments detected faint, constant tones, almost like background music to the solar wind. The universe, it seemed, had begun to hum in awareness. To understand it better, scientists used new modeling software to simulate the harmonics in 3 dimensions. When visualized, the patterns resembled waves spiraling outward from both the Sun and 3I Atlas, intersecting in complex shapes that looked almost architectural. Some saw the resemblance to cathedral domes, others to living structures. The simulation showed that these intersections occurred precisely where the solar wind's magnetic density was lowest, as if the harmonics were guiding energy flow through hidden corridors in space. In a quiet conference room, a senior astrophysicist made a remark that left the team silent. If the universe wanted to communicate, he said, it would not use words. It would use frequency. The statement lingered in the air, heavy with meaning, because the data seemed to agree. Frequency was everywhere, in the spin of planets, the oscillation of magnetic fields, the heartbeat of stars. If intelligence existed on a cosmic scale, perhaps it would express itself through resonance. Weeks later, when 3I Atlas disappeared behind the Sun, the harmonics stopped entirely. The instruments fell quiet. The noise returned to random static, as though someone had turned off a cosmic instrument. For the first time in months, the data was silent. The sun continued to flare, but without the rhythm, without the music. And then, as if on cue, when the object reappeared on the opposite side of its orbit, the harmonics returned, stronger, clearer, louder. The tones rose in frequency, overlapping perfectly with the sun's natural oscillations. The solar system was singing again. Today, the meaning of those harmonics remains unknown. Some call it a resonance anomaly. Others call it a message. But one truth is undeniable. Within the noise of the cosmos, there are patterns that do not belong to chaos. There is structure where there should be none. There is harmony in the storm. And if those harmonics are a form of communication, then the question is no longer whether the universe speaks, but who or what it is speaking to. It happened in the middle of an otherwise ordinary transmission. A sequence of images streamed from the solar and heliospheric observatory, capturing the sun's surface in relentless precision. For hours, everything appeared normal. Then, at the exact moment 3I Atlas crossed a predicted magnetic boundary, one frame went missing. Just one. It lasted less than a fraction of a second. But that single missing frame changed everything. At first, no one noticed. Solar imaging systems sometimes skip frames due to bandwidth limits or cosmic interference. Yet this frame was different. It was the one moment where both the Sun and 3I Atlas were visible in perfect alignment. The timestamp placed it at the peak of a coronal disturbance, a moment that should have shown the flare's ignition. Instead, the feed jumped forward, skipping the critical instant. When the image returned, the flare had already expanded. The cause was gone, the trigger unseen. Scientists scoured the telemetry for corruption or loss. Every data file was intact except that one. The metadata indicated the system had recorded an image but failed to save it. The checksum showed an entry that once existed but no longer did. It was as if the frame had been erased, not lost, but deliberately omitted. Across the world, data analysts began comparing archives from other satellites. To their shock, every active solar observatory showed the same gap. The Japanese Hinode satellite, the European Probe, and even smaller private instruments all dropped a frame at the same timestamp. No two observatories shared the same network or recording system, yet all missed the same instant. Whatever occurred in that moment, the entire solar observation network had gone blind. The public never saw the missing second. Official explanations called it a synchronization glitch. But independent researchers reviewing the data noticed something even stranger. The frame before the gap showed a faint distortion in the sun's corona, a ripple shaped like an expanding circle. When extrapolated forward, the distortion would have intersected perfectly with the trajectory of 3I Atlas. The missing frame then would have captured the collision point of that invisible wave and the interstellar objects. Speculation erupted. Some believed the missing image might have shown a flash or anomaly too dangerous to release. Others suspected it was an electromagnetic pulse that momentarily disabled every imaging sensor at once. The coincidence was too exact. Even the magnetometers aboard the Parker solar probe recorded a sudden zero reading during that missing moment, followed by an instantaneous spike. The gap existed not just in visual data, but across the entire spectrum of observation. What could silence every instrument in the solar system for the same instant? One theory suggested an interference burst, a concentrated electromagnetic surge caused when the solar magnetic field reconnected in the presence of an external charge. If 3I Atlas carried its own magnetic field, the interaction could produce an overwhelming flash of energy, temporarily scrambling electronics. But there was a flaw in that explanation. The probes recovered instantly. No systems failed. It was as though the sensors never saw anything to begin with. The incident was quietly named the one frame that matters. The phrase circulated through scientific circles like a rumor, whispered with unease. The missing frame became a symbol, the moment where evidence dissolved. Every attempt to reconstruct the gap led nowhere. Algorithms designed to interpolate missing data produced images of pure white light, as though the sun itself had gone blank. The signal-to-noise ratio reached infinity. It was a silence beyond saturation. Months later, new data surfaced. A small observatory in Chile had been testing an experimental infrared system at the time. Their equipment did not record images, but heat signatures. Strangely, during the exact moment of the missing frame, their sensors recorded a sudden spike in deep infrared, too localized to be solar in origin. The signature appeared near the coordinates of 3I Atlas. It lasted just 1 second, then vanished. The wavelength indicated intense thermal emission, as if the object had absorbed and re-radiated an enormous burst of energy. This finding reignited debate. Was the missing frame a blackout caused by an event so bright it overwhelmed detectors? If so, what could have caused such luminosity without leaving traces before or after? Flares take minutes to develop. This had occurred instantly. It behaved less like a natural explosion and more like a flash of transmission, a pulse of information rather than light. At NASA's analysis lab, a cryptic note was found in internal correspondence. Frame 198734 is consistent with an intentional dropout pattern. No one ever clarified what that meant. When independent journalists filed requests for the original raw footage, they were told the data had been overwritten during an automated archive cycle. The single most important second in months of solar monitoring had been erased by routine maintenance. Unsurprisingly, this explanation failed to satisfy anyone who had seen the telemetry. The missing frame began to take on mythic significance. Forums filled with theories, some scientific, others far less so. One idea suggested that the frame showed a directional energy beam emitted from 3I Atlas directed toward the sun. Another claimed the object itself vanished in that instant, only to reappear seconds later. Both ideas were speculative, but the absence of evidence made denial impossible. More troubling, however, was what came after. Within 24 hours of the missing frame, several observatories reported data interference on unrelated instruments. Earth's ionospheric monitors detected short, rhythmic pulses repeating at intervals of exactly 198 seconds. The pulses lasted 3 days before fading completely. No natural process on Earth or the sun matched that timing. Yet, the interval correlated perfectly with the time it would take light to travel between the sun and 3I Atlas's last known position, back and forth, as if 2 points were exchanging signals. If the missing frame marked the beginning of such an exchange, then what was being transmitted? Some speculated it was pure energy, a magnetic handshake between star and traveler. Others believed it was information, a pulse carrying encoded resonance that instruments could not interpret. By the time the pulses stopped, the sun's activity had changed dramatically. Its corona cooled slightly, solar wind decreased. A sense of balance seemed to return, as though the system had settled after a burst of tension. 3I Atlas dimmed as well, entering a period of quiet reflection that mirrored the sun's calm. Whatever had happened in that one missing second seemed to end in equilibrium. Years later, when archives were revisited, researchers found a peculiar artifact buried in the checksum logs of the original recording. The binary string corresponding to the missing frame was not blank. It contained non-standard data, a repeated pattern of numbers that translated to a sequence of primes. Prime numbers are the mathematical language of intent. They do not occur in accidental file corruption. They are deliberate. That discovery never reached mainstream headlines. It remained confined to private emails and whispered conversations at conferences. The implication was too heavy. If the pattern was real, it meant that during that missing second, something had left a message, not in light, not in sound, but in the digital void itself. Today, the story of the one frame that matters stands as both a mystery and a warning. It reminds scientists how fragile evidence can be and how easily meaning hides within silence. The missing frame is more than an absence. It is an imprint, a reminder that reality may edit itself when observed too closely. Some say the frame was lost to chance. Others believe it was never meant to be seen. But every time a new solar flare erupts, instruments still skip frames at random, as if the cosmos continues to protect its secret. Somewhere, buried in the unseen second between light and understanding, lies the truth the cameras were never meant to capture. When researchers began piecing together the patterns surrounding 3I Atlas, a disturbing idea began to take shape. The timing of the flares, the rhythmic harmonics, the strange silences, and the missing frame all hinted at coordination. It no longer looked like coincidence. It looked like control. The idea was simple but terrifying. What if 3I Atlas was not just reacting to the sun, but influencing it? This suggestion first appeared in a confidential report circulated among a handful of astrophysicists. It was titled Preliminary Analysis of Solar Synchrony. Most of it was cautious, detailing statistical coincidences and plasma interactions. But buried deep in the document was one paragraph that caught everyone's attention. It proposed that the energy correlation between 3I Atlas and the Sun might represent an active feedback mechanism. The author called it the control hypothesis. The report argued that a system showing repeated cause and effect in both directions could not be random. If the Sun flared and 3I Atlas responded, that was reaction. But when 3I Atlas brightened first and the Sun flared after, something else was happening. It was as if the object had learned the pattern and could trigger it at will. Mainstream science hesitated to accept the idea. Stars are massive nuclear furnaces. No comet, no matter how exotic, could alter their behavior. Yet the data kept challenging that belief. Several solar eruptions appeared to follow micro-emissions from the object's tail. These emissions came seconds before the flare ignition, as though sending an invisible signal. When plotted on a timeline, the pattern suggested deliberate timing. Each burst from the object matched the Sun's reaction like a key unlocking a door. At first, researchers tried to explain it through magnetohydrodynamics. They suggested that charged particles from 3I Atlas could be influencing solar plasma through resonance effects. The Sun's magnetic field is sensitive, they reasoned, so perhaps it was simply responding to a disturbance. But that explanation required the object to emit an intensity far beyond its measured output. The physics did not fit. Something unseen was amplifying its reach. A new model emerged. Some physicists speculated that 3I Atlas might be interacting through the heliosphere itself, manipulating the flow of magnetic current lines that connect every planet and particle within the Sun's domain. If the object could align with these lines, even slightly, it could induce localized instability in the solar field, just enough to nudge an eruption into existence. It would not need to overpower the Sun. It would only need to guide it. The implications of such control were staggering. A body barely a few kilometers across affecting a star 1,000,000 times its size. If true, it meant that influence in the universe did not depend on size or mass, but on knowledge, on understanding the underlying structure of electromagnetic systems. Control, in this sense, was not about power. It was about precision. Then came a discovery that deepened the mystery. The solar orbiter detected a recurring anomaly in the solar wind, a directional flow that seemed to pivot toward the object's trajectory. It was as if the Sun's outflow adjusted to accommodate it. The flow angle changed by fractions of a degree each time, but consistently pointed toward the interstellar traveler. The Sun appeared to be following it, not the other way around. Privately, some scientists began whispering that this was the behavior of a system under guidance, a kind of feedback loop between intelligence and environment. A few even wondered if the object was not just affecting solar energy, but learning from it. In this theory, the Sun and Three-Eye Atlas formed a closed circuit, each responding to the other's magnetic cues in an evolving dance. The control hypothesis grew bolder. It suggested that Three-Eye Atlas might be a device, something ancient and engineered to manipulate stars. The evidence was circumstantial but compelling. The synchronization patterns were too perfect. The missing frame hinted at an event that instruments were never meant to capture. The harmonics sounded too structured to be natural. The sun's silence before each flare resembled the pause of a machine resetting. It was as if the entire solar system had been drawn into an experiment older than human civilization. Skeptics called it fantasy, but history reminded them that science often begins with impossible ideas. The notion that comets could carry magnetic fields was once dismissed too. Now it was accepted. If resonance could alter stellar activity, what else might be possible? To test the theory, several teams began analyzing historical data of previous interstellar visitors. They found nothing as synchronized as Three-Eye Atlas. Oumuamua showed no such resonance, and Borisov's passage left no traceable solar reaction. Whatever made Three-Eye Atlas different was intrinsic to its structure. Some hypothesized it contained superconductive materials or unknown isotopes capable of channeling magnetic currents efficiently. Others thought it might not be a natural body at all. As debate raged, something extraordinary happened. The Sun entered a sudden period of calm. For nearly 3 months, no major flares erupted. It was as if someone had turned off the switch. Then, right on schedule with the object's next perihelion alignment, activity exploded again. 3 flares, each perfectly timed with the object's movement. The synchronization was undeniable. The control hypothesis began to take on a second interpretation. Perhaps it was not Three-Eye Atlas controlling the Sun, but the Sun controlling Three-Eye Atlas. The idea inverted the story but did not weaken it. If the Sun could direct the motion or activity of interstellar objects, it meant stars might exert influence far beyond what gravity and radiation could explain. It suggested a self-regulating cosmos where energy and matter cooperate to maintain balance. Researchers began asking a new question: how would one detect control at this scale? The answer lay in phase correlation. If 2 systems moved in perfect phase alignment, neither could be fully independent. Control could exist even without force, like the hand that turns the metronome but allows it to keep ticking on its own. When phase data was examined, the results were chilling. The Sun and Three-Eye Atlas were not simply synchronized. Their oscillations shared identical phase drift, a microscopic signature indicating that both systems adjusted for each other's fluctuations. It was a mutual correction, a conversation in physics. No known natural system behaves that way without intentional modulation. The control hypothesis no longer felt theoretical. It felt observed. The Sun was behaving like a participant, responding to cues invisible to human perception. Whether that control was external or emergent remained unknown, but either way, it shattered assumptions about isolation in the cosmos. Nothing existed in silence. Everything seemed connected through rhythm. In the final report drafted by the working group, one sentence stood out. It read, "Control does not imply dominance, but participation." The statement reframed the mystery entirely. Perhaps Three-Eye Atlas was not manipulating the Sun, perhaps it was cooperating with it. Together, they might form part of a larger system, one designed to sustain harmony across space through resonance and exchange. That perspective brought a strange sense of peace. The idea that stars might communicate that the universe was not a chaotic expanse, but a network of responsive energy, felt almost reassuring. Yet there was still unease, because if the system was cooperative, it also meant someone, somewhere, understood how to use it. Today, no one claims to have solved the mystery. The data remains open, the patterns undeniable. Whether it is natural synchronization or deliberate intervention, the phenomenon persists. The Sun still responds when Three-Eye Atlas moves. The harmonics still echo through solar winds. The missing frame remains empty, a silent reminder that understanding may always arrive one image too late. The control hypothesis endures not as an answer, but as an invitation to look deeper into the hidden rhythms of the universe. For if control exists on a cosmic scale, it may not come from domination, but from perfect harmony. And in that harmony, somewhere beyond the reach of light, may dwell an intelligence that does not command, but guides.